Good morning, Algebra Lab. Today's personalized learning lesson will be aimed towards achieving this objective. I can write equivalent expressions using the distributive property. So this is a short video to teach you about the distributive property before you go into your activity. The distributive property can be represented by this formula. A, B, and C are all variables here in the formula, but normally they'd be represented as a mixture of numbers and variables. But you see when you have A on the outside of the parentheses and B and C on the inside, you're distributing what's on the outside to what's on the inside, which gives you AB and AC. Here's a different representation of it to show you that whether it's plus or minus, you can distribute either way. And when you multiply two variables together, it's like they get glued together. So A times B is A. Here it is represented with, sorry, let me move my video, represented with numbers. So when we have 5 on the outside and 6 minus 3 on the inside, you could simplify first and do 6 minus 3. But if you wanted to represent it with the distributive property, or if you wanted to split up the work, you would simply do 5 times 6 and 5 times 3. And this isn't simplified all the way, but you'd simplify further by doing 5 times 6, which is 30, minus 5 times 3, which is 15. So your simplified answer would be 15. So notice what happens when we multiply a whole number by a variable. We saw A times B was AB. When you do 8 times X, you get 8X. Again, they're glued together. Then you have 8 times 3, which is 24. And then you have to ask yourself, can I simplify this any further? But because 8X has a variable with it and 24 does not, they're not like terms, so you cannot simplify further. So this slide shows distributing and simplifying by combining like terms all together. So you distributed the 4 to the x and the y because they're inside the parentheses. And next you could do this step, or you could just go ahead and simplify without rearranging, but rearranging helps get your terms in order so that the like ones are together, like 4x and 5x. And then the next line down, you would want to simplify by combining the like terms that go together. So 4x plus 5x, you add the coefficients, which are the numbers in front of the variables, and then bring down what can't be combined. And then you'll notice, oh, I can't combine any further because I have an x, a y, and a constant. So that would be the simplified version of this expression. So in the activity you're going to do, you're going to see distributive property represented as area. So you have length and width as 6 and a 4 and a 10 because it's broken up into two different rectangles. But to show the distributive property on these, you take your length, which is 6, and multiply it once by 4 and once by 10 because those are both part of the width. And to distribute, you would multiply. You could also think of distributive property as ordering off a menu. If you were going to get 6 tacos, you wouldn't go up and say, I want a taco, a taco, a taco, and a taco. You would say, I would like 6 tacos. So here we'd see that maybe there's 3 people ordering 2 tacos, but they're all on the same bill. So you could distribute the 3 people times the 2, and you'll realize that is 6 tacos. And then if all 3 people want a drink, 3 times D would be 3 drinks. So distributive property isn't just a silly thing we do in math. It can actually be beneficial in real life situations like finding the area of something or in ordering off a menu. And there's many more examples. I'd love for you to bring some to class tomorrow. Okay, now it's your turn. You're going to complete the Desmos activity and make sure when you're done with each answer you hit submit so that they are sent to my side of the website, and this is what it will look like. So you're doing this pool party and you're finding the area of the deck in the pool based on distributive property. So go ahead, do your best. Let me know how I can help, and I'll see you tomorrow.